Bismillahirrahmanirrahim. Assalamu alaikum dear students. We are now starting the third lecture for week number 8 of our course for communication systems. In our last lectures we talked about some basic concepts related to probability theory. In today's discussion we will be discussing very important concept which is of random variables. Random variable is very interesting concept in the probability theory that enables us to represent outcome of a random experiment as a number. So we know that all random experiments, they have certain outcomes. So those outcomes can be represented as a number by using this concept of random variable. However, you should notice that although the name is random variable, so it is not a variable, actually it is a function. So random variable is basically from mathematical perspective, it's a function that generates numbers corresponding to outcome of a random experiment. So how do we define this random variable? The random variable is actually a rule or a function or a relationship, typically we denote it by some capital letter like x, and this rule or this function assigns a real number to every point in the sample space. So actually random variable is a rule that assigns a number corresponding to the outcome of a random experiment. So how do we see that number? So this sample space is actually the domain of the function, and the outcome of the numbers, they are range of this random variable x. You should notice that each random point each sample point generates one number in the domain, so in the range. So you can see that you have a fixed outcome corresponding to each sample point. You should notice that each outcome represent one number in the number line. However, two outcomes can be represented by same number, like illustrated in x2 here. So these three outcomes, they are represented by same number. However, reverse is not true. So one number cannot assign to two different sample points. So each outcome has a one number that is associated with that particular outcome. So this is an important point, which is also the concept of function in mathematics, that when you get the output, so it will be a unique value. So these random variables, they can be discrete or continuous. So there are both possibilities of having this random variable. So if the sample space contains countable number of points, so of course the x will be having a discrete values or countable number of values in the random variable. So based on those discrete values, of course we get a discrete random variable. So one example is the number of packets arriving at a computer terminal during a specific time interval. You can see that the number of packets will be a discrete number. For example, there are 5 packets arriving or 100 packets arriving, but it cannot be an arbitrary number. So it will take only discrete values. Similarly, we can have continuous random variables. Those continuous random variables, they can take any value between a certain range. So actually there are infinite possible values associated to continuous random variable, though those are restricted to certain range. A simple example is the phase angle we received in a wireless environment. So typically the phase angle which is received is random, and it can take value between 0 and 2 pi. So it can take any value between 0 and 2 pi. So it is a continuous random variable, because there are between 0 and 2 pi there are actually infinite possible values, but and those values they occur continuously. So eventually the random variable that is associated with that event is actually defined as continuous random variable. An important thing is that one experiment can define number of random variables. So there is a possibility to define more than one random variable corresponding to one single event in the one single random experiment. Let me try to elaborate that thing using some example. Say for example, we have a simple problem that we have an experiment of throwing a fair die. So a fair die is thrown. So we know that if you throw a fair die, in that case the possible outcomes will be 1 to 6. So there are 6 possibilities, 1 2 3 4 5 6 numbers they can appear at the outcome. So we have to define a random variable. So how can we define? As I said, the random variable is defined as a rule to assign a number to outcome of a random variable outcome of the experiment. So we have the rule that we have defined is that x is the random variable which assigns 1 if the number is even. So if we get an even number at the output, we will assign it 1. Otherwise, if it's an odd number, we will assign 0. So this is our rule. So if I ask you to what is the range of x, so what that means what values x would take. So eventually x can take only two possible values, either it will take 0 or it will take 1, because whenever you get an even number you will assign 1, and whenever you got an odd number you will assign 0. So this range is between 0 and 1. You should also notice that each value corresponds to some event. For example, if I ask you to find the probability of event defined by x is equal to 1. So think about the event which is x is equal to 1. X is equal to 1 means all those values which are even numbered. So for even number, the event will be 2, 4 and 6, because these three values are even, represent the even outcome. So if we say x is equal to 1, that means we are referring to an event which has value 2, 4 or 6. So if we find the probability, it comes out to be 1 upon 2, as we have three possible outcomes corresponding to this event and the total sample points are 6. So therefore we get 1 upon 2 at the output. Similarly, if I ask you to find the probability of x is equal to 0, x is equal to 0 correspond to the event which shows an odd number at the outcome. So odd number is 1, 3 and 5. So eventually if you calculate the probability, it comes out to be 1 upon 2. Let us take another example. A fair die is tossed, but this time I have defined a different random variable. So the x denotes twice the number appearing on the output. So the value of x will be twice of what you get at the output, whereas y is defined as 1 or 3 according to if we get an odd or even number at the output. So you can see that we have used a different definition for the random variable. So eventually you will get different ranges of x and y. So if I ask you to find the range of x, you can see that the x would take double values. So eventually the range of x will be 2, 4, 6, 8, 10 and 12. So these are the possible values that x can take, whereas y can take only two values, which are 1 and 3, depending on the whether the outcome is an even number or odd number. If I ask you to find the event corresponding to x is equal to 4, what is the event corresponding to x is equal to 4? You can see that x is equal to 4 is this value, and this corresponds to the event when you get 2 at the outcome. So the event defined by x is equal to 4 is 2. Whereas if I ask you to define the event for y is equal to 3, y is equal to 3 means you get an even number at the outcome. So eventually the event will be 2, 4 and 6. So y is equal to 3 corresponds to the event that you get either 2, 4 or 6 at the outcome. Let us take another problem. Let's say we have a source which generates 4 possible symbols A, B, C and D. Each symbol is generated with certain probability, and probabilities are given as 1 upon 2, 1 upon 4, and C and D has same probability, which is 1 by 8. In order to transmit these symbols, we have used a coding scheme to represent the symbols using binary codes. So A is represented by 0 only, B is represented by 1 0, C is represented by 1 1 0, and D is represented by 1 1 1. So these are the codes that are used to represent those symbols. So let us define a random variable. So random variable is defined as the length of the code. So you can see that the length of the code is 1 for A, for B it's 2, for C and D both has 3 digits in the code. So the length of the code for C and D both is 3. So our random variable x is defined as the length of the code, that is the binary digits in the symbol. So what is the range of x? You can easily see that the x can take either 1, 2 or 3. So there are only 3 possibilities for x, which are 1, 2 and 3. We also want to find the probabilities corresponding to x is equal to 1, x is equal to 2, and x is equal to 3, and x is greater than 3. So for x is equal to 1, that means we are referring to the event that A is transmitted, and we know that A probability of A is 1 upon 2. So for x is equal to, probability of having x is equal to 1 is 1 upon 2. Similarly, probability of having x is equal to 2 means we are asking about the probability of transmitting B, which comes out to be 1 upon 4. However, probability of x is equal to 3 corresponds to the event whether C is transmitted or D is transmitted. So it includes both C and D. In that case, the total probability with sum of these individual probabilities, and this comes out to be 1 upon 4. If I ask you to find the probability of x greater than 3, you can see that in our coding scheme there is no code which has the length which is greater than 3. So having greater than 3 means we are talking about a null set, because there is no such code. So it has a probability which is equal to 0. So you can see that in this way we can assign assign numbers to outcome of a random experiment, as we briefly discussed, and depending on the assignment we get the random variable and its ranges and probabilities. So let me quickly discuss the two different types of random variables. One is the discrete random variable. So we'll start our discussion with discrete random variable. The question is, how can we mathematically describe the behavior of a discrete random variable? So mathematical description of a random variable is very important, because we have to include that discussion in our analysis whenever we need to go for certain analysis. There are two commonly used representations to define the behavior of random variable. One is called probability mass function, and second is called cumulative distribution function, CDF. What is probability mass function? Probability mass function actually gives you the probabilities related to individual occurrence of random variable, or each value of random variable need to have is represented by that particular probability mass function. Whereas cumulative distribution function is defined by this relationship, that it shows the probability up to certain point or less than. So it is actually sum of all the probabilities up to that particular point. So in order to illustrate this difference, let me give you a simple example that we have previously discussed as well. Consider the random experiment of 3 coin toss. So we have an experiment of 3 coin tosses. We have previously discussed that when you toss 3 coins, in that case the total outcomes are 8. So the sample space contains 8 sample points. We have defined a random variable that how many heads occur in a toss. So number of heads are represented by the random variable x. So you can see that in the toss you can see either 0 heads or 1 head or 2 head or 3 head. So the random variable x would take these values 0, 1, 2 or 3. For x less than 0, there will be no event because x cannot take any value which is less than 0. So of course the probability corresponding to this value of the random variable, that is x less than 0, is of course 0. So both PMF and CDF, they are 0. If I ask you to find the probability corresponding to x is equal to 0, you can see that the x is equal to 0 is represented by only one outcome. That means we do not get any head, so we get all tails in the outcome. So we are talking about 3 tails in the outcome. So there is only one sample point that corresponds to this particular event. So if I ask you to find the probability, so this probability comes out to be 1 upon 8, because total sample points are 8 and we are talking about only one sample point here. Similarly, for x is equal to 1, that means we are talking about the case where only one head appears in the outcome. So this condition is reflected by 3 possible sample points, THT, TTH and HTT. So these are 3 sample points corresponding to this value of random variable x. So if I ask you to find the probability, we can easily find the probability. We can simply divide 3 by 8, because there are total 8 possible values in the sample, 8 sample point in the sample space. So the probability comes out to be 3 by 8. If I ask you to find the probability corresponding to x is equal to 2, x is equal to 2 means we are talking about the case where are 2 heads in the outcome. So 2 heads in the outcome appear with 3 different possibilities, that is head in first toss, or tail in second, and head in third, or first 2 heads and then tail, first tail and then 2 heads. So there are 3 possibilities which corresponds to this value of x, and eventually the probability would come out to be 3 by 8. So PMF has a value of 3 by 8. Similarly, for x is equal to 3, we are talking about all 3 heads. So there is only one possibility that you get all 3 heads. So eventually the probability would be 1 by 8. And if I ask you to find the probability corresponding to x greater than 3, of course x cannot take any value greater than 3. So eventually it corresponds to a null set. So eventually the probability will be 0. So these are representing the values of probability mass function. However, for CDF, as I mentioned earlier, that CDF corresponds to sum of all probabilities until that point. So for x less than 0, of course CDF is 0, because there is no sample point before that thing. So there is no probability of having x less than 0. However, for x less than 1, we have probability 1 by 8. So if I add 1 by 8 to 0, so eventually you would see that the result comes out to be 1 by 8. For next, for x is equal to 1, we have the probability to be equal to 3 by 8. So what is CDF? If I add this 3 by 8 with this 1 by 8, you can see that the total probability comes out to be 4 by 8. So it actually represents sum of all probabilities until this point. Similarly, for x is equal to 2, if I add the probability of x is equal to 2, which is 3 by 8, with the previous CDF value, which is 4 by 8, so 3 by 8 is added to 4 by 8, which comes out to be 7 by 8. And at the end, if I add for x is equal to 3, we have to add this 1 by 8 to 7 by 8 in order to get the CDF value. If we add them together, it comes out to be 8 by 8, which is equal to 1. And eventually, for at this stage, the total probability comes out to be 1, because this is the maximum possible value of the random variable. So beyond this point, you would only see 1 as the value of this CDF. So eventually the final value of CDF would be 1. So starting value of CDF would always be 0, final value of CDF would always be 1. In these graphs here, I have illustrated the PMF and CDF of this case. So PMF takes this value. For x is equal to 0, the probability is 1 by 8. For x is equal to 1 and 3, the value is 3 by 8, whereas for x is equal to 3, the probability is 1 by 8. CDF, because it shows the summation, so you can see that it's starting is 0, then at x is equal to 0 it becomes 1 by 8, then at x is equal to 1 it becomes 4 by 8, then at x is equal to 2 it becomes 7 by 8, and at x is equal to 1 it becomes 1, and beyond that it will retain its constant value 1. So the final value would always be 1 for CDF. These are some common properties related to discrete random variables. The CDF, as I mentioned, CDF, the minimum value of CDF is 0 and maximum value comes out to be 1. CDF is actually an increasing function. You can see that it's an increasing function. It never decreases, rather with new value the function increases. So if we go towards higher values of x, we will see that the CDF increases or remains constant. The final value of CDF means at infinity you would always see the final value to be equal to 1. The initial value, that is at x is equal to minus infinity, mathematically the initial value will always be 0. If I ask you the properties of PMF, you can easily see that the PMF gives you the of course it's a probability, it represents a probability, so it can take value between 0 and 1. So there is no other value, only 0 and 1. The PMF would have some value only for the points where you have a sample point xk. If x is not equal to xk, if you see any other points other than the sample point, the probability will definitely be 0, because it has the value only for those points where you have occurrence of any event. Similarly, if I ask you to find the sum, which is the standard property of the probability function, that summation of all possible values or possible probabilities is always equal to 1. So this is equal to 1 here. Now let us start discussing related to continuous random variable. As I mentioned, in the case of discrete random variable, there are two commonly used descriptions of random variable, PMF or CDF. Similarly, for continuous random variable, we have two common representation. One is the probability density function, and second is the cumulative distribution function. CDF has the same concept even in the continuous random variable and discrete random variable, that is its sum of the probabilities up to that particular point. So it has the same concept. The only difference is that in this case we are now referring to continuous random variable instead of discrete random variable. So what is the probability density function? By definition, it shows a distribution of probability with respect to random variable. You can see that probability density function is not the probability, it's a probability distribution. If you compare it with this probability mass function that we discussed for discrete case, PMF gives you exact probability, it's an exact probability here. But PDF does not show the exact probability, rather it's a distribution. So how do we get the probability? The probability is actually area under the curve of this PDF. So if you want to find the probability for certain event or certain values of the random variable, you have to find this area under the curve, and mathematically we find this area through integration. So say for example we have two points A and B, and we want to find the probability that our random variable has value between A and B. In that case, this probability is calculated by integrating this CDF function, this PDF, which is represented by px here. PDF is represented by px here. So we have to integrate it from point A to point B. So the result of this integration, which represents this shaded area, is actually gives you the probability that your function x gets a value between this A and B. And of course, this PDF is actually related to the probability, so this PDF must be a non-negative function. In any case, PDF cannot be negative in any case. And second, the total area of this PDF function is always equal to 1. It should be unity, because this is the standard probability property of the probability function, that the total probability always comes out to be 1. So if I ask the standard relationship between CDF and PDF, so the PDF and CDF, they are related with this derivative relationship. This PDF can be calculated by simply differentiating the CDF of any function. Conversely, if you want to find CDF from PDF, we can get it by integration. So we have to integrate from the lowest possible value, which is minus infinity ideally, to whatever point we are considering x. So if we integrate the PDF to our point of calculation, so we will get the value of CDF at that particular point. The properties of CDF are same as we discussed before for the case of discrete random variable. As I mentioned that the concept of CDF is same for both cases of discrete and continuous random variables. So it has the same properties. So let me quickly summarize the properties of PDF here. So first property is that PDF should be a non-negative function, as I previously mentioned, that this PDF is directly related to the probability, which cannot be negative. Therefore, the PDF should also be greater than 0. Secondly, if I integrate the CDF in entire range means mathematically the minimum value is minus infinity and maximum value is plus infinity. If I integrate to entire range, so this integration should come as 1. So it is the area under the curve should be unity. Third is fx is a piecewise continuous function. It should be a continuous function, so it has values at all possible points. Fourth point, if we want to find the probability in any range, so this probability is calculated by integrating the PDF in that particular range from A to B. However, at this stage, it is important to mention that for continuous random variable, so these all cases, they are actually mathematically same. Probability of having A less than or x and less than equal to B, or probability of having A less than or equal to x and less than equal to B, or probability of having A less than equal to x and less than B, and probability of having A less than x and less than B, they represent the same case in continuous. In discrete random variable, they are different. In discrete cases, of course, you have to consider whether the point is included or not. But for continuous random variables, all these 4 possibilities, they are exactly same, and they are calculated in same way. From PDF, you have to calculate by integrating, and from CDF you have to calculate by calculating the difference between the CDFs of 2 points. Means you have to subtract the CDF of at point B with CDF of point A. In order to conclude the discussion, let us take a simple problem related to this continuous random variable. We have a continuous random variable x, which has certain PDF, which is defined here. Fx is kx between this range 0 to 1 and 0 otherwise. You can see that there is an unknown number here, k, which is a constant number, and in order to proceed further, we have to calculate the value of k for this function. So how can we calculate the value of k? We know that from our standard properties that the PDF has certain property that if we integrate to entire range, the result of integration should come out to be 1. So if we integrate this entire range, this CDF, you can see that the integration should be performed from 0 to 1 because our random variable exists in this particular range between 0 and 1. So if we integrate and simplify it, we can see that this k by 2 comes out to be equal to 1, and from there we can find out that k has a constant value which is equal to 2. So simplifying, we can write our PDF with this expression: fx of x is equal to 2x for x between 0 and 1 and 0 otherwise. So this is the value of PDF that we get. I have plotted this function PDF here. You can see that from 0 to 1 for values of x 0 to 1, it's plotted. It's a straight line because it's a linear relationship. Second point is that we want to find, and of course we will sketch it, the CDF of x, fx of x. CDF is to be calculated. You can see that from PDF we can calculate CDF simply by integrating. We have previously discussed that the integral of this PDF is actually the CDF. However, in this particular case, we have to calculate this CDF for 3 possible ranges because there are 3 possibilities here. Our random variable exists in this range between 0 and 1. So, between 0 and 1, x is variable. Before 0, of course, the function is 0, and after 0, this PDF is also 0. So, we have to calculate the CDF in these 3 ranges, that is for x less than 0, for x between 0 and 1, and for x greater than 1. So we have to calculate for these 3 values. For x less than 0, of course, since CDF is 0, so we cannot we will have 0 value of CDF as the PDF is also 0. So CDF has a constant value which is equal to 0. For between 0 and 1, we have to use this standard formula of integrating this function up to that variable x. So if we integrate the function, now we start our integration from 0 because the variable starts from 0. So from 0 up to the variable x, if we integrate the CDF, we will see that the function comes out to be x square. So CDF has the constant value which is x square. And for x greater than 1, again we have to integrate, but this time we are talking about values which are greater than 1. However, we know that the range of values of our random variable is between 0 and 1. Therefore, we have to integrate from 0 and 1. So it's a constant limits here. And if you simplify after this integration, you would see that this value comes out to be 1, which is, of course, we know that the final value of the CDF. So this is the result of CDF. You can see that for less than 0, the CDF is 0. For x greater than 1, CDF has a constant value which is CDF equal to 1. And in between, CDF is represented by this function x square. So it is plotted as a quadratic function as x square here. Okay, this brings us to the last part, which is finding the probability of having random variable between 1/4 and 2. This probability can be calculated in 2 ways. Either you can calculate by using this PDF value. In order to calculate through PDF, you have to integrate from the lowest point to the highest point, which is 1/4 and 2 in this case. So you have to use this relationship. Alternatively, we can calculate using CDF as well by simply subtracting the value of CDF at the upper value, subtracting the lower value with the higher value of the CDFs. So if you subtract these two values, eventually you can find the probability. So for this case, I have calculated the probability by using CDF. However, it can be calculated by PDF as well. And I encourage all students to try calculating by using PDF on their own, and you would see that you would get the same result with PDF as well. So if we calculate, so at whatever CDF value is at 2, x is equal to 2, we have to subtract the value of CDF at x is equal to 1 upon 4. So at x is equal to 2, we know that for x greater than 1, the CDF has a constant value which is 1. So at x is equal to 2, the CDF is 1. Whereas for x is equal to 1 upon 4, we have to use this relationship. At x is equal to 1 upon 4, CDF is given by x square. So it should be written as 1 upon 4 squared. And if you simplify this thing, you would see that the result comes out to be 15 by 16. So the probability of having x between 1 upon 4 and 2 is given as 15 by 16. So for today's discussion, we have talked about the distributions we use to represent discrete random variable and continuous random variable, and we also discussed general properties related to those distributions, that is PDF, CDF and PMFs. So we stop our discussion here. Thank you all.